The Sun is a star at the centre of our solar system. It is one of the billions of stars in our galaxy, the Milky Way. It looks larger than the stars in the night sky because it is far closer to Earth. It is only 150 million kilometres away. The next nearest star is Alpha Proxima, more than 40,000 billion kilometres from Earth. The Sun is a spherical ball 1.4 million kilometres wide. Its vast size makes it 100 times wider than Earth and 1 million times the volume of our planet. The Sun is so massive it contains more than 99.8% of all the mass in the solar system. Because it is so huge, the Sun's gravity is powerful enough to influence objects across massive distances. The Sun's gravity keeps everything in our solar system, including planets, asteroids, and dwarf planets, locked in orbit around it. The Sun is 75% hydrogen, and most of the rest is helium. These are the lightest chemical elements. They are also the most common elements in the universe. The Sun also contains small amounts of oxygen, carbon, neon, and iron. Nuclear reactions deep inside the Sun created these heavier elements. There are three main parts to the Sun. The core at its centre is the hottest part. Deep in the Sun's core, temperatures reach 15 million degrees Celsius. Around the core is the radiative zone. Heat is carried through this area away from the core. Around that is the convective zone. Heat moves through this zone like soup bubbling in a pot. The visible layer of the Sun is called the photosphere. The temperature of the photosphere is about 6,000 degrees Celsius and gives the Sun its yellow colour. The Sun also has an atmosphere. A small part of the Sun's atmosphere escapes into space. We call this the solar wind. It takes 50 million years for the Sun's energy to travel from the core to the surface, and then another 8 minutes for the light to reach us here on Earth. Scientists have worked out that the Sun is about 4,500 million years old. It formed from part of a giant cloud of gas and dust. The pull from the cloud's gravity caused part of the cloud to clump together and collapse inwards. As the gas and dust fell to the centre, the temperature and pressure increased. The Sun began to shine when the temperature reached 1 million degrees Celsius. Stars evolve and change with time. The Sun is currently in a phase of its life called the main sequence. It shines and releases energy through a process called nuclear fusion. The heat and pressure in the cores of main sequence stars create the right conditions for lighter atoms to fuse together and make heavier ones. Scientists estimate that in around 5,000 million years' time, the Sun will run out of the fuel needed for nuclear fusion. It will then swell and expand into a red giant star. Some stars explode once they run out of fuel. The Sun is not big enough to explode. Instead, it will lose its outer layers over time. We call this a planetary nebula. The central core of the Sun will shrink to a dense white dwarf. Finally, it will dim, stop shining, and become a black dwarf. The changes that the Sun will undergo late in its life will have severe implications for life on Earth. Scientists think one of two things will happen as the Sun expands to a red giant star. Either the Sun will completely swallow the Earth, destroying our planet in the process, or the much wider Sun will stretch further out into the solar system, leading to scorching temperatures on Earth. But remember, there is another 5,000 million years before this happens.